Hi, in this video we're going to be talking about polyhedron, which are solid objects whose surfaces are all polygons. This is a polyhedron down here, and it's made up of faces, edges, and vertices. Now the vertices are the little corner spots on this shape. So we've got them where we kind of get like a little corner on the polygon, or where there's an intersection of edges. So this one has 1, 2, 3, 4, 5, 6, 7, and I missed this one right here, 8 vertices. So we could say V equals 8 in this polyhedron. The edges are the segments that are connecting these vertices. So I'm not going to mark all of them, but it's the idea of these 2 points being connected. That's an edge. These 2 points being connected, that's an edge. So everywhere you're able to connect two blue dots. Now we don't want to go from something like this one to this one because there's not a line connecting those 2 points. But we can see we've got 1, 2, 3, 4 on the bottom. We've got 1, 2, 3, 4 going up the side. And if you think about that top, you've got another 1, 2, 3, 4 on the top. So there are 12 edges. So E equals 12. Then we've got the faces. Faces are the polyhedron uh, or the polygons that make up the sides of the thing. So if I look at this kind of shape right here, this is the connection of all 4 of those dots kind of being surrounded by our edges. Those are the faces of our polyhedron. So we got the bottom and the top, and then we got 1, 2, 3, 4 going around them. So there are 6 faces on this thing. Now the faces of this geometric object, they are these kind of like tilty rectangles. We know those are parallelograms. The edges are those lines that go from one point to another point, so that is a segment. So going from one point to another point, that is just a segment. It's not a line because it doesn't keep going. And then finally, those vertices are all points. Now, these vertices are always going to be points. The edges are always going to be segments, but the faces are going to be different shapes. They could be a triangle. They could be a circle. They could be a rhombus. They could be all kinds of different things. So this one changes, but the others don't. Now, there's this cool formula about polyhedron called Euler's formula. That says if you've got a polyhedron, like we've got down here, the number of faces plus the number of vertices is going to equal the number of edges in that polyhedron plus 2. Otherwise, we might have a net, which is this thing. This is if we took this three-dimensional object and kind of unfolded it and laid it flat. Think about if you were to make this box out of cardboard, how would you cut it out of a flat piece of cardboard? You'd cut it like this, and then you'd fold along these edges to kind of close up the box. If you've got a net, it's also faces plus our vertices, but then it's going to be the number of edges on that shape plus 1 rather than plus 2 if you've got the folded up polyhedron. So let's check that out. So if I'm looking at this one, the number of faces in this polyhedron, I've got the top and the bottom, so that's 1, 2, and I got 1, 2, 3, 4, 5 faces that go around the outside. So there are 7 faces plus the number of vertices that are in that object. So those vertices are all of these points. We got 1, 2, 3, 4, 5 around the top and 1, 2, 3, 4, 5 around the bottom. So that's going to be 10. And that should equal the number of edges that we have plus 2. It's always going to be a plus 2 on the end. So we got to just count up our edges now. So let's see, we got 1, 2, 3, 4, 5 around the top. We've got 1, 2, 3, 4, 5 around the bottom. And we have 1, 2, 3, 4, 5 going up the sides. So that means we have 15 edges. So we'll see if this works out. Well, 7 plus 10, oh, that's 17. And that equals, hey, 15 plus 2, that is 17. So Euler's formula works for that polyhedron. If we're doing this with a net, it works the same way. We check our faces. We got 1, 2, 3, 4, 5 faces. So faces is 5. Plus, we need to count up our vertices. So if I count my vertices, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I've got 10 vertices. That's going to equal the number of edges that I've got plus 1 this time because I am doing this with a net, a flat version of the three-dimensional object. So I got to figure out my edges. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So I'm counting all of the segments for the edges, all the kind of corners for the vertices, and then the polygons for the faces. So 5 plus 10, that's 15. And we want to see if does that equal 4 plus 1? Hey, that is 15. So Euler's formula works. That's it for our video on polygons. Note that they can be squares or pentagons or hexagons, all kinds of different shapes for these polygons. The idea is that they are made up of a collection of vertices, edges, and faces. Thanks for watching. Bye-bye.